All right, now what we'd like to do is look at how regression is related to ANOVA. Whoops. ANOVA. Okay, I'll spell it here right sooner or later. ANOVA and chi-square. So remember that in regression, we will have our explanatory and response variables here, and we'll see some cloud of data, and maybe like here it looks like I've made it have a trend. Now, if I move from numerical data here on the x-axis, so suppose I was just doing something like suppose this was just height and this was just weight. Oops, keep hitting the eraser. Then, right, we would probably expect as somebody gets taller, they get heavier. As somebody is heavier, you might expect them to be taller. So, that would be our prediction usually. And so we have, maybe data that look kind of like this, and we could run our regression analysis on it. But I could also, instead of having height like, oh, they're 5'2", 5'3", 5'7.5", 5 foot, instead of using that as numerical, for whatever reason, I could decide that, well, what I'd rather do with height is list them as, so here's still my height, but I'm going to list them as just low, medium, high, or short, medium, tall, or something like that. So maybe short, medium, and tall. And if I were to list them that way, now I could, what I'm doing is wherever I decide short begins and ends, right? I'm going to divide my data over here. Here are all the short. And then, in here are all the tall, and here are the medium. And so if I were to plot that way, I would just get dots, sort of along these lines. And, stuff like that. I just fill in those dots like that. Now, of course, if you have repeats of numerical values and so forth up here, so here's our weight. There's Y. So, I could get something like this, but what does this remind me of? Well, actually, what I would get more information from, instead of just plotting the dots here, is if I had my box plots on each of these. And, gave you something like that, but pretty much we're doing the same thing with just the dots, just not giving you as much information. Here, with the dots, I can see the max and the min, so I can see that and I can see that, but that's about it. Because I can't really tell if one dot's sitting on another dot. I could have 10 dots all sitting on each other, so I really don't know for sure where the average or the median might be. And these usually show us the median of the distribution and the quartiles. And so, we get this. But notice, once I put it into this framework, right, this was a regression. Now, this, I would use an ANOVA if my data looked like this. Okay, so if I categorize that numerical height data and put it into columns, as we would have had with ANOVA, so a column for short, medium, and tall, now it's ANOVA data. And notice it's got the same sort of trend here. Now these are ordinal categories. By taking the numerical and categorizing it, I would think, always get ordinal categories, so it makes sense that there's an order to these and there really is a trend. But in the end, even if there's not that particular trend, the ANOVA could have, I could have gone up at first and then down, and the ANOVA doesn't care. It just wants to know if these things are different. So something like this is fine. But with the numerical data, you really can't talk about ordinal, and so I probably wouldn't mix up the order of these different box plots in this case. I would put them from small to tall or tall to small, one of the two. And, or I guess it was short. I was rhyming, reading a lot of Dr. Seuss lately. So short to tall or tall to short. And but that relation is that same data, right? Same data here and here, same data, but two different tests. Same question, two different tests. And we can go further and we could categorize along both axes. So here we could have our short, medium, tall, and weight we could have low, medium, and high weight, in which case then our data that we had up here, we sectioned it this direction, but we also section it in the Y direction. And what we do is we just count things up. And so here, as I count this up, it looks like, whoops, I don't know what I just did, but hopefully I didn't erase anything. Nope. Now you see I have my 3x3 grid, and if you look up here, I'll actually try to, here has 0 up there and just 1 maybe in there, and similar sort of things. So we see 0, 1, it looked like 1 there, 1 there. And we have more, so we'll call it 4 and 3, 4, 3, 1, 2, 3, 4, 5, 6. It looks like 6, and maybe 3 or 4 over here, so 6 and 3 there, I think it was, and then 2, 4, 6 up there. Okay, so I count how many points are in each of those, and now I have my contingency table, and I would do a chi-square. And again, I can see within this table, and really these should be moved over, I guess, now that I've placed them in there. So low, medium, high. But I can see in my table that trend of, as I move this direction, the amount goes up in this direction, right? So here I had mostly, I had more down at the low end when I was over here, but then as I moved to the right, the most were more in the middle there, and as I moved to the right more, the most were there. And so I see that same dependency that I saw here with that trend, and that I saw here with that trend. And so, again, if I categorized all my data into something like this table, for whatever, I just decided I wanted to use categories instead of actual weights. Maybe that's all I needed to know was, they were above a certain weight or between two weights or below a certain weight. And that's what mattered to me. And so I just counted. It is the same data. We're just using it, we're summarizing it in a different way, and we still want to know the same question. Is there a dependency between the height and the weight? And it certainly looks like there might be here, because as I change rows, the proportions look different. And they're, in this case, again, because we went from numerical variables, and so, we can actually talk about trends. There seems to be this trend of moving up, for my highest proportion in a given row to move right as I move up, or another way to say it is the highest proportion in a given column moves up as I go right. Oh wait, I got myself mixed up as to what I was talking about. But right, so if I look at a given row, right, as I look at a given row, well, as I move up on those rows, I think I'm saying it right this time. As I move up on those rows, right, the largest proportion in the row is moving to the right. Something's happening that looks like a dependency. Or if I look at the columns, okay, as I move right on the columns, the largest proportion in the column seems to be moving up. There, I said that correctly that time. So it's the same stuff. Different test because we've put our data into categories and counts. So a different test than either the ANOVA or the regression. If I categorized just the one, I would go with the ANOVA. If I didn't categorize any of them, I would go with the regression. Okay, so that's how regression is related to ANOVA and chi-square, in that I could take the numerical data and run these different tests. I just have to summarize my data a little differently for each test. Okay, there we go.